Number 8. A car attempts to accelerate up a hill at an angle theta to the horizontal. The coefficient of static friction between the tires and the hills is mu is greater than tangent theta. What's the maximum acceleration the car can achieve in the direction upwards along the hill? Neglect the rotational inertia of the wheels. Let's first draw the force body diagram. So we have the inclined plane, and then our car will represent this small circle, the point mass. And then we have a force of gravity acting downward. Oh, and don't forget our theta. And force of gravity is, as always, mass times the gravity. And then we're gonna draw the normal force that's perpendicular to our motion. And also we need a friction that resists sliding down. Okay, and we can find the force of motion due to the gravity by using a simple trick, and that is we can draw a we have the identical force of normal force, and then we have the motion, the force due to the gravity in our motion, or the motion that's caused by the force of gravity. That's gonna be our this is gonna be our corrected version. Why? Because I'm gonna make the system instead of saying this to be x and y, I'm gonna make this to be positive, the motion along the plane to be the positive x, and the perpendicular to that to be positive y. Okay, that makes our calculation much easier. And okay, in case you're still confused, let me clarify by drawing the coordinate system. So I have x and y here, and then so all I'm doing is tilt it this way, and this positive x, or the x direction, is corresponding to our motion of our car. Okay, so I think that's quite clear. So moving on, I'm gonna draw this okay, I'm gonna write down all the necessary information. So f of g is mg simply, and then the force of Newton must be used by our trig function, and that theta is similar, or that theta is same thing as our incline, and these two, the small triangle and the large triangle, represent the similar triangles. So when we use the theta and the f of g here, we can find both the motion due to the gravity. I think that might be better. So that's that. It's parallel. And in the vector, you can have, you can pull this out and move anywhere as long as you are not changing the magnitude and the direction. Okay, so force of Newton is equivalent to this, right? Okay, for now, let's just say this is force of Newton because they cancel out. The motion, the car is not moving up and down along our plane here, so they have to be equal. So this green, you see the green line, the green vector, is our force of Newton, and that turned out to be f of g times the cosine theta, because this is adjacent to our theta. Therefore I can write force of Newton times force of cosine theta. Oh, what am I doing? Okay, that has to be g. Alright, so that becomes mg cosine theta if you want to simplify further. And I'm gonna write down the corrected, maybe it's better to have a f not there, corrected force along our motion, and that's gonna be f of g sine theta, because now we have the vector that's opposite to our angle, so f of g sine theta. Okay, and we have to find the force of friction. And how do we find that? Well, by definition, the force of friction is mu times the force of normal, and we already found the normal here, force of normal, so that turned out to be mg cosine theta. So mu times mg cosine theta is the force of friction, so that's done. And we already found the force of motion due to the gravity, so this is taken care. And force of normal is not going to really play a big role, other than that we had to find the force of friction. So we're pretty much done, at least for our preparatory step. Now I'm going to separate into two. Okay, so now I'm going to separate into the force of net, and we want to find the maximum acceleration. So on the right side I'm going to have mass times the acceleration maximum for our f of net. And looking at that, since I declared this to be positive, the F friction to be positive, that has to be positive, so I write it first, and then the force due to gravity has to be negative. So now I can stack them up. Force of friction mu mg cosine theta minus, okay, this can be rewritten as mg sine theta. So now I write that here, mg sine theta equal ma maximum. Notice I can divide both sides by m. So m's cancel out throughout and leave me only mu. Okay, g can be pulled out and we can distribute that out. So mu times cosine theta minus sine theta equals our maximum acceleration. Do we have an answer? The answer is B. Alright, and you might also wonder, why did they give us this? The mu is greater than tangent theta. Or some might wonder, oh, do I have to use this piece of information to solve this? Well, as you see, I didn't have to really worry about that, but I'm just gonna clarify that this was given to prevent students' confusion. So for example, I can derive this, or I can write this in much more clear term by rearranging it. So I'm gonna have mu is greater than tangent theta, so I write that first. I'm gonna multiply both sides by mg. So I have and then split the tangent into sine theta over cosine theta. And then cross multiply the cosine theta to the left side. So I eventually have this. So where do we see this? The mg sine theta. Well, we saw it here, right? Mg sine theta. That turned out to be the motion due to the gravity. And where do we see the mu mg cosine theta? We already saw here. So that represents our force of friction. So this is saying that force of friction is much larger than the force due to the gravity. And it has to be that way, because if that's not given as it is, it can violate our given direction when it says the maximum acceleration that car wanna go upward. Okay? So this is just reassuring that there's no problem with the given question.